Alright, section 11.4 talks about the quadratic formula. The quadratic formula, it's a very specific formula. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now the most common mistake students make when they're writing out the quadratic formula is they forget to extend this fraction bar all the way across. This is one big fraction. This negative b is not out front, but it's part of the numerator. Okay, so make sure that entire thing is covered with the fraction bar. And notice here you've got a plus or minus here. So typically you'll have two answers. Now that's the case if this thing underneath the square root is positive. Right? If this thing under here is positive, you're going to have this guy plus this over 2a and this guy minus this over 2a. Now if this guy is 0, right, plus or minus 0 is nothing, so you just get negative b over 2a, you get one number. Now if this guy is negative, you don't get any real answer because you can't take the square root of a negative number. So you either get two answers, one answer, or no answers. Alright, but this is the quadratic formula. It's a formula you definitely need to know. I recommend you write it on a big piece of paper, put it on your refrigerator, and put it on your bathroom window, bathroom mirror, and you'll see it twice a day. And by the time you end up taking a test over this stuff, you'll know it. Alright, so they talk about the stopping distance for a car if a car sees a deer on the road, and they ask you how much of a braking distance, how fast can you go if your braking distance is 500 feet from when you see the deer. So what's the maximum speed you can be going and still have time to stop in time to not hit the deer? Alright, so they say what if the distance is 500 feet? Well, the distance, stopping distance you need is based on whatever your speed is x, and it's 1/9 x squared plus 11/3 x. And what they do is they set that distance equal to 500 feet, and when you can figure out what x is, that will answer your question as to how fast you can be driving that fast or slower and still be able to stop a safe distance. Right? We'll talk about that in a minute when we do one of the other examples. But for right now, they give you the quadratic formula. Like I said, this is it. And your a, b, and c, your a is the well, you have to throw everything to one side, set it equal to 0 first. And then the a is the x squared term, the b is the x term, and c is the constant. Alright? And if you've got fractions or decimals, you want to get rid of those. If you've got more negatives than positives, you can multiply everything by -1 and make it more positives than negatives. You can change it somewhat by multiplying by some number. And that way when you plug things into here, you don't want to plug in fractions or decimals. You can plug in negatives, mind you, but not fractions and decimals are tough to work with the quadratic formula. Alright, so we got 2 is your a, -3 is your b, c is your -1. So negative whatever b is, plus or minus the square root of b squared. Notice it's in parentheses because it's a negative number and I'm squaring it. Minus 4 times my a times my c all over 2 times a. Well, -3 is 3. -3 times itself is +9. -4 times 2 is -8 times the -1 is +8, so you're adding 8 there. And 2 times 2 on the bottom gives you 4. And so the 9 plus 8 gives you 17, and so this is it. 3 plus or minus square root of 17 over 4. So it's 3 plus root 17 over 4, or 3 subtract square root of 17 over 4. Now if you're going to type this into your calculator to figure out the approximate answer, you better put it in parentheses. Otherwise you're only dividing the square root by 4 and not the 3 by the 4 as well. Right? Notice, by the way, when you graph it, you've got two x-intercepts. The x-intercepts are the places where this thing equals 0. So when you graph it, wherever it crosses the x-axis, those are your answers. And when you solve each one approximate, you get 1.78 or -0.28. 1.78, a little bit less than 2, and -0.28, a little bit less than 0 there. All right. Now what if it has only one solution? Well, that's going to happen when you plug in these numbers and you take the square root and you get the square root of 0. Well, the square root of 0 is 0, and plus or minus 0 is just 0. So your numerator is just -20, and -20 over -50 is -2 over 5. And so you get one answer. And again, look at your graph. Your graph only touches at one spot. Notice whenever you graph these quadratic equations, wherever it crosses the x-axis is your solution. In this case, your solution is negative 0.4 or negative 2/5. Notice there's only one answer. When your item underneath this square root equals 0, you get one answer. When the item underneath here is positive, you get two answers. When the item under there is negative, you don't get any answers. Right? Here's one where there's no real solution. Right? When you plug in all those numbers into the quadratic formula, you get the square root of negative 59. And you can't take the square root of negative 59, so there's no real solution. Okay, and when you graph it, you see it doesn't cross the x-axis. See, it doesn't come anywhere near the x-axis, so it does have a no solution answer to it. Now here's the question about the stopping distance. If you have 500 feet to stop, what's the fastest you can possibly be going and still have time to stop? So you got 1/9 x squared plus 11/3 x equals 500. Okay? And so if you just multiply everything by 9, well, first you bring the 500 over the other side, makes it negative 500. Then if you multiply everything by 9, make everything 9 times bigger, gives you nice whole numbers to plug in. And when you plug in all those whole numbers, you get this guy here. And when you simplify this down, you got this guy plus that, and the same guy minus that, both over 2. And when you solve each one, you get negative 85 or positive 52. Well, you can't be going a negative speed, so the negative number's out. But positive 52 miles per hour, that's your answer. So you can be going 52.6 miles per hour or slower and still have time to stop before you hit the deer. Now the item under the square root has a very specific name. It's called the discriminant. It's the b squared minus 4ac. That will determine what type of answers you get. So if b squared minus 4ac is positive, there's two real solutions. The very first problem we did had two answers. If the item under the square root equals 0, you get one answer, and that's what we got for the second example. And then if the item underneath there is less than 0, it's no real solution. They're actually complex solutions. All right? So you can have problems that have no x-intercepts, ones that have just one x-intercept, or ones that have two x-intercepts. If they have no x-intercepts, they don't have any solution to the equation. If they touch in only one spot, they only have one solution. If they touch in two spots, they have two solutions. So now they say analyze the graphs of the quadratic function. So you can see right here, first off, it has two solutions at positive 2 and negative 3. Now they ask you to state whether the a is positive or negative. Well, if this thing is pointing down, a is negative. If this thing is pointing upward, it's positive. Well, the fact that this thing is pointing downward, you know a is negative. All right. Now they say solve this guy equal to 0. Well, you know wherever it crosses the x-axis is your solution. So it's positive 2 and negative 3. Now they say determine whether the discriminant is positive, negative, or 0. The fact that we got two real answers means it is positive. It has to be positive. And now they say use the discriminant to determine the number of solutions. So they don't ask you to find the answer. They just ask you to find, well, I guess they eventually do, but they initially ask you how many solutions there are. So you got to figure out what b squared minus 4ac is. Remember, your a is 4, your b is minus 20, your c is 25. And you plug those guys into b squared minus 4ac and you get 0. So you should get one answer. When you simplify this down, you end up with plus or minus the square root of 0, which is plus or minus 0, which is nothing. And so you just get 20 over 8, which is 2.5. And so again, you get one answer. And because you got a discriminant equal to 0, you get one real solution. That's what we thought was going to happen, and that's what did happen. So here's our quadratic formula. You plug it in and you simplify it, and normally you'll get two answers. Sometimes you get one, sometimes you get none. It just depends on how the numbers work out. So you can solve it by hand doing the quadratic formula. You can graph it and find the x-intercepts, or you can look at a table and find out where y equals 0. Where y equals 0, those are x-intercepts, and those are solutions to your equation. So here's the similar questions. And the first question gives you this guy here with a is 1, b is negative 6, c is negative 16. And you plug all the numbers in. Negative b plus or minus b squared minus 4 times a times c all over 2a. And you simplify everything down. You want to be real careful with your signs here. Negative 6 squared is positive 36, and the negative times the positive times the negative is going to be positive, and they add up to give you 100, and square root of 100 is a 10. And so now you got two possibilities. You got 6 plus 10 over 2, and you got 6 minus 10 over 2. And each one will give you a different answer. 16, same idea. You got 2, negative 9, and 7. Plug them in, and you reduce it down to here, and the square root of 25 is just 5. So you got two possibilities. This guy plus 5 over 4, and this guy minus 5 over 4. And each one gives you a different answer. And same thing here with this one. When you simplify it down, it doesn't reduce your square root as nicely as before, but it does give you an answer. 1 plus square root of 17 over 8, and 1 minus square root of 17 over 8. Two separate answers. Okay, and then this one, notice they give you 36, 36, and 9, and 0, so you can divide everything by 9 first. Make your numbers a lot smaller, right? So now you got nice whole numbers, and you plug them in, and you multiply it out, and you get the square root of 0, and square root of 0 is nothing, so you just get 4 on the top here. 4 over 8 is a half. Now if you didn't change it, and you used 36 minus 36 and 9, you'd still get the same answer. Your numbers would just be bigger, and it'd take a little bit longer to work it out, but you would still get the same answer, whether you divide it by 9 first or not. Multiply everything out, bring the 2 over, and notice everything's got a 2 in it, so I divide it by 2. And I use these three numbers in my quadratic formula, and I get down to here and I get two answers. This plus 13, root 13 over 2, and this minus root 13 over 2. You gotta write it in descending order, so you gotta multiply everything out here first. You gotta multiply x times x, x squared. X times 1 is x. Minus 1 times x is minus 1x. Minus 1 times minus 1 is minus 1. So it's first times each one, second times each one. Each one of these times each one of these. So you got 4 different multiplications there. You got the plus 2 and you got the 4x. Now when you bring the 4x over here, or first you combine everything on this side, and then when you subtract 4x you get this guy here, and now you've got it in descending order. X squared, x, and a constant. There's your a, b, and c. Plug them in, simplify it down, and notice here you can reduce this. Square root of 12 is the square root of 4 times 3. And square root of 4 is just 2. But the square root of 3 doesn't reduce. It stays the way it is. Now, you can divide each one of those by 2. 4 over 2 and 2 root 3 over 2. 4 over 2 is just 2. And these 2 cancel, and you're just left with the square root there. So that's your answer. 2 plus square root of 3 and 2 subtract square root of 3. Now in this one you got a lot of fractions. Multiply by a common denominator here, 4, to get rid of your fractions. Bring everything to one side, and there's your a, b, and your c. You simplify it down, and you get the square root of 9, which is just 3, and that gives you two answers. 5 plus 3 over 4 and 5 minus 3 over 4 gives you these two answers here. And this one, I don't like using an a of negative, any negative sign for my a, so I typically multiply or divide by negative 1 to make my a positive. That way my denominator is a positive number. But that's just my own preference. You don't have to do that. So plug in these three numbers in the quadratic formula, and you reduce it down, and you get the square root of 40. Now square root of 40 is the square root of 4 times 10, and the square root of 4 is just 2, but the square root of 10 doesn't reduce. Now 10 over 6 and 2 root 10 over 6, each one separately reduces down to 5/3, and a 2 cancels there, leaving you a square root of 10 over 3. And this one I plugged in all the a, b, and c's, and I reduced it down to here the square root of 8 is square root of 4 times 2, and the square root of 4 is just 2, and you still have another 2 under there that you can't get rid of. And so now each one of these divided by 2 is 2 root 2 plus 2 root 2 over 2. Each one has that same denominator of 2, and this is just 1, and that cancels, just leaving with the square root of 2. So you got your two answers, 1 plus root 2 and 1 minus root 2. Okay, so you plugged in your a, b, and your c, simplify it down, you get the square root of 25, which is 5, and you got your two answers there, minus 3 halves and positive 1. Same thing here with the A, B, and C. The only difference is when you simplify, you get the square root of a negative 19, which means no real solution. Here, when you plug in your A, B, and your C, notice there's no B term, there's no X term, so B is 0. So you have to be careful there. A is 1, B is 0, C is 11. Alright, and you plug in everything, you simplify it down, and you're taking the square root of negative 44, which you can't do, so no real solution. And then here, when you plug this in and you crunch it down, you get the square root of negative 56. Again, no real solution. And then 33, I think they give you a question. Let me check. What is the original question? It says, 33 says x squared minus 2x minus 1. It says use the quadratic formula to find any x-intercepts of the problem. Well, your a is 1, since a is positive, and you end up with here, I'm not sure how we get x equals 2 and minus 1 on this, because that looks like a different answer here. This one looks like you're using quadratic formula with 1, negative 2, negative 1. I don't know why I'm doing this here. That's a different question. Same thing with this one. Looks like they're asking you, maybe it's these questions here, where they ask you to evaluate the discriminant. So you'd plug in b squared minus 4ac, and you'd get 49, and that would tell you have 2 discriminant answers. You plug in b squared minus 4ac, and you get a discriminant of 0, so you're going to have 1 answer. And here you plug in your a, b, and your c after you bring everything to one side, and you get a discriminant of negative 23, so there's 0 real solutions. And this one, when you have to multiply everything out. You have to multiply the 4x times each one, the minus 1 times each one. You got to add 25 and bring everything together in descending order, and then you can finally figure out your a, b, and your c. Then you can figure out what b squared minus 4ac is. It's negative 279, which means 0 real solutions. And 97. Looks like they give you a quadratic equation, and if you want to solve this one, you multiply by 100, and then you can divide by 25, make your numbers smaller. And when you plug everything in, you get square root of 81 under the radical, and so it just becomes 9. So it's 7 plus 9 over 4, or 7 subtract 9 over 4. Each one gives you your own specific answers. And then this one I think is the same thing as the stopping distance, but they're changing the stopping distance to 726 feet instead of 500 feet. So you subtract 726, and you get this, and then you multiply everything by 9 to get rid of your fractions. And you got some weird numbers here, but you can just be careful and watch everything out and simplify it out, and you get the square root of this is 165 exactly. So you either get 66 or negative 99, and since you're talking about a speed, you can't go negative 99 miles an hour. So you can go as fast as 66 miles an hour and expect to stop within 726 feet. This one's talking about a sidewalk, and they want to have a sidewalk that has width x, and it surrounds a garden that is a 40 by 30 garden. All right, and so the sidewalk is basically the outer rectangle minus the inner rectangle will give you this inner rectangle part. All right, that's the area you're looking for. So if you take the outer rectangle, or outer rectangle, and subtract the inner rectangle, you end up with this region on the outside here, which is the area of the sidewalk they're doing there. Now, if this is 40, and your width of your sidewalk is x and x, that's 40 plus 2x. If this is 30, and this is x and that's x, this is 30 plus 2x. And so your outer rectangle is 40 plus 2x times 30 plus 2x. That's the outer rectangle. And the inner rectangle is just 40 times 30. And so if you take the outer rectangle minus the inner rectangle, you get this. And you have a total of 624 square feet of cement to use. And so they're asking you to multiply all this out and throw everything to one side and use quadratic formula, and you find that x is either negative 39, which makes no sense, or x is 4, meaning 4 feet. So if you can make a 4-foot wide sidewalk surrounding this garden that's 40 by 30 and be allowed to have enough concrete to do that. So what you did there was you assumed that the sidewalk width was the same all the way around. It's x. X here, x there, x there, x there, x there, x there, right? X is the width all the way around. And if this is 40, this is 40 plus 2x. If this is 30, this is 30 plus 2x. And so you take the outer rectangle, this guy times that guy, they're there, and the inner rectangle, 40 times 30, that guy, and when you subtract them, you're left with this zone here, which is where you're going to be pouring your concrete. So when it's supposed to equal 624 square feet of concrete, that's the amount of concrete material you have. So when you multiply everything out, you got to multiply times the 30, that times the 40 times that, 40 times that, 2x times that, 2x times that, and 40 times 30. And you bring everything to one side and write it in descending order. And you use your A, B, and your C in the quadratic formula, and you do all the work down here, and you get down to two numbers, 4 and negative 39. And the answer's got to be the 4, because you can't have negative 39 feet. Alright? Where is the rest of this? So, when you're doing your problems, I say solve by using the quadratic formula. Okay, so you get 1, negative 5, negative 14 in the quadratic formula. 4, negative 8, 3, quadratic formula. Same thing here. Same thing here. Here you got to do some work. Here you got to multiply by 3x times the x, 3x times the negative 5, and then you got to bring the 3 over here as well, and you got to write it in descending order in order to figure out what the quadratic equation formula is going to have for your A, B, and your C. Here you got to multiply everything out and bring everything to one side and combine like terms. So you got to multiply x times x times 2, minus 2 times x, minus 2 times 2. And then take all those terms and add 6 and subtract 6x, write it in descending order, and then do the quadratic formula. Now here you're going to want to multiply by 15 to get rid of your fractions. All right. Here you could multiply by negative 1. You don't have to, but it might make it easier on you. Here you don't have to do anything with it. Just use your A, B, and your C that you got there. Same thing here. Okay. And same thing here. Notice they say use quadratic formula to find the x-intercepts on the graph. That's the same thing as the solution to this guy equaling 0. This guy equals 0 will tell you what the x-intercepts are for this graph. And you can graph it. And how do you find the x-intercepts on a graph? You hit second trace 2, and you move to the left of your x-intercept, hit enter, move to the right of your x-intercept, hit enter, and move back to the center and hit enter, and it will find your x-intercept for you. All right, and do the same thing here with A is 1, B is 0, C is 14. Same thing there. Okay. So here they say state whether A is positive or negative. The fact that it's pointing up tells you A is positive. All right. Now they say how many solutions are there? There's 2. Well, you can tell one of the solutions looks like it's around 7, and the other one's like maybe negative 1 or negative 2. So I would say x equals 7 and x equals negative 1. Those would be my 2 solutions. And I would know that the discriminant has to be positive for me to have 2 real solutions. Now this one, I know A is negative because it's pointing down. Okay, and I know it has 0 solutions because it doesn't have any x-intercepts. And thus I know the discriminant is negative. No solutions, no real solutions means discriminant is negative. All right. Now this one, your discriminant has to equal 0 because it has only one solution. And we also know A is negative because it's pointing down. Discriminant is 0 because it has only one solution, one x-intercept. Okay. On this one, they want you to evaluate the discriminant, so you'd have to multiply everything out and write it in descending order and then figure out what b squared minus 4ac is. And then you can answer the question there. And on this one, I'd multiply everything by 100 first to get rid of my decimals. Then I'd use those numbers there. And then here I'd multiply everything by 9 to get rid of my fractions and use the quadratic formula there. And then 20 is just like what I did on the other problem. If you got 27 here and your width is x, this is 27 plus 2x. And if this is 33, this outer edge is 33 plus 2x. So take the outer rectangle, this guy times that, minus the inner rectangle, 27 times 33. And that has to equal the amount of concrete you have, which is 544. And you can find the quadratic formula that way.